We are only going to be looking at one main way to solve differential equations, and that's going to be separation of variables. There are lots of ways that you can solve differential equations. Those are just beyond the scope of this class. If you go into college and you're going to go into like engineering, medical field, math, okay, you will take an entire class that is differential equations, and you learn how to solve all sorts of different types of differential equations. So like we are just touching like the tip of the iceberg, just kind of like show you what differential equations are and a couple of applications in our next section. So just realize that like this is just barely hitting the top of what you can do with differential equations. But the technique that we're going to use is separation of variables. And quite literally, we are going to separate the variables to two sides of the equation. Because remember that these are differential equations, which means they are equations with derivatives. And how do we undo derivatives? Antiderivatives, which are integrals, okay? But if I have a dy dx, okay, I don't want to take the integral of that, because that would be taking the integral with respect to y and the respect to x. And that would be multivariable calculus, which is like calculus 3. So that's not what we're doing here. So we're going to only take the derivative with respect to y or x, which means that we have to separate them out. So our first step is to write dy dx. Now, sometimes the dy dx will already be in there, so you can just skip that step. But sometimes I'm going to be given a y prime or an f prime. And this is one of the few cases where like we cannot use y prime or f prime notation. We have to use the dy dx, otherwise I can't separate the dy dx if it's not there. Then, as it seems, we're going to separate y's to one side and x's to the other. Now, I put y's and x's here as like a placeholder. You could technically have h's and t's, or r's and s's, okay, dr, ds, whatever it is, you're going to separate the two variables one to both sides. Now, dy dx is the most common, but you can see any of them. Then we will integrate then we will simplify or solve as needed. So sometimes our answers, we're going to solve for y. So like directions will sometimes say like write the answer in terms of x, okay? Which means that like you need to have an equation for y, okay? Sometimes we're going to get an answer that has like y squareds in it, and we don't want to have to solve that. So we might simplify a little bit, but we're not going to solve it all the way down, okay? Now this gives us our general solution, which remind me has what in it? Constants, yeah, okay? And then the particular solution, what do we have to do? We have to use the what?
Initial condition.
The initial condition to solve for C. If you're given one. If we're not given one, then we're just going to leave it as a general solution. If we are, then we'll find the particular solution. Today we're going to focus on just the general solutions. Yes, no me. So let's look at an example. So I have 1 over y, dy dx equals 2. So we already have our dy dx built in, so we don't have to do anything with that. On the left hand side, what do we have right now? What variables? Y and x. What do we want?
Just y.
Just y. Okay. So notice that my dy is already on top, so it's easiest to leave that as y's. Okay, so then how would I move my dx to the other side? Cool. So now have I separated out my variables?
Yes.
So then what's our next step?
Integrate.
Integrate. Now I did have someone ask second hour, do we have to like draw in the integrals every single time? No. As long as the reader, aka me, or like for the AP test, whoever is grading your question, can tell that from this step to this step you integrated, right? Then you would still get points. The only time that it's kind of helpful to put that is if you're needing to go back and like check your work. Then sometimes it can be helpful to be like, how did I get this line all of a sudden if you put your integral symbol there? But you don't have to. So then what is the antiderivative of 1 over what? Natural log of absolute value of what? What is my antiderivative of 2? What are we forgetting?
Plus c.
Plus c. Now technically I took the antiderivative on both sides, so like you could put a plus c with each of those, but then notice that I could just add or subtract that c over here, and it would still just be a constant. So we generally only put a c on one side or the other, and basically that has scooped up all of the constants that could be in there. Yes? Alright. Now this is one that would be easy enough that we could solve for y. What do we do to solve for y there? In other words, what undoes a natural log?
E.
What do I want to do with the e? Is not really multiplying. So like I just like multiply, that does not undo it.
Plug it in for y.
We don't want to plug it in.
E to the 2x plus c.
Yeah, so I make my e the base, and I write each of them as the exponent of e. So remember, it's called exponentiating, which you don't really have to remember that word, just that I raise both sides to the power of e. And the reason that we do that is because e to a natural log undoes each other, and I'm just left with the absolute value of y. Yes? No? Maybe. Ah. So the next step we need to remember are exponent rules. If I have x to the a times x to the b, what does that equal?
X to the a plus b.
So, does that mean could I go the opposite way? If I have two things that are being added together, I can break them apart into multiplication. Yes, no, maybe? I
Yes.
Okay, now if c is a constant, what will e to the c be? Also a constant, yes? So we're just going to write that as a c. Yes? And remember that in order to drop absolute values, I would have to put a plus or minus, yeah? But is plus or minus c still just a constant? So again, we let that c kind of scoop up all of the possibilities. And we would figure out if c was positive or negative by plugging in an initial condition. So most of the time with your differential equations that end up having an e in them, you're going to see your constant in the front, and it's because they've rewritten it this way. What questions do you have there? free response question, you're fine to leave it like the third to last step, right? You don't have to do it this way. But as a multiple choice question, they are gonna rewrite it. Alright, and here we go. What do we notice about this one?
There's the constant.
We already have a constant. Okay. What else?
There's X's and Y's on both.
We have X's and Y's, like both sides this time. So we're gonna take care of that. So if I have dy dx, again, what did we say is easiest to move over? The bottom. So I'm gonna multiply both sides by a dx. Okay. But now, what's our issue on the left side? Sorry, right side.
There's still a Y.
There's still a y. Okay. How do I get rid of the y?
Did you divide them on this?
Mm-hmm. Or the same thing as
Multiplying by 1 over Y.
I separated my variables. Yes? Okay, so now what do we do? Integrate. What is the antiderivative of 1 over y?
Natural Y, absolute value Y.
We're gonna have that a lot in these. What would we have to do in our other side?
You sub?
So remember that the whole point of all of our integration techniques was that we could take the integral of lots of different things, and so now we're applying those techniques, so we still have to use all of those. So what is our du?
2dx plus dc.
No. C is just a
Constant.
constant, and the derivative of a constant is 0, so I don't have anything. So I do have to divide by a 1/2. So then notice we would have 1/2 times 1 over u du. What's our antiderivative of that?
1/2 natural Y absolute value.
Okay. And I just did that over to the side so that way I didn't have to like write my equation like 5 times. Okay. So I still have 1/2 times the natural log of the absolute value, and I'm just gonna plug my u back in. But be careful because this c came from my original equation. It is not my integration constant, so I have to add another constant. You could either label that as like c sub 2. I tend to use k because I don't want subscripts in there. So again, how would I simplify this? If I wanted to solve for y.
Raise everything to E.
I'm not raising it.
Make E the base for everything.
There you go. I'm exponentiating. So I'm just left with the absolute value of y on the left hand side. Now, notice on the right hand side, I have an e and I have a natural log in the power, so I want those to like reduce. They will not right now because we have a 1/2 there. Can we do something with that 1/2?
Make E square root.
Hmm?
Do you make it into the square root of E because it raised to 1/2 power as a square root?
Not of e.
Square root of natural log.
Ish.
Natural log square root of 2x.
There we go. So remember that one of our properties for natural logs says that I can rewrite constants as exponents of the inside of stuff. So I can raise 2x plus c to the 1/2 power. So it's like in inside of it. And then remember, same thing as before, I can also rewrite this as a times e to the k. Because now, I just have just the natural log on the inside, so that will reduce. And we also know that e to the k is also just a constant, so I'm going to move that to the front. So I end up with k times the square root of 2x plus c. Questions on that?
What happened to the absolute value? Then we just do.
Here,
Yeah.
can the square root be negative? So it's redundant to write it. And then I drop my absolute value on my y because remember my k can be positive or negative, so it like swoops that up. Other questions? So we're continuing on. What we have here. There's not a dy dx, and what did we say we need? But what is y prime the same thing as? dy. Alright. I can just write it in. Okay, then I want you to do this one on your own. Alright, so we're first needing to, I'm going to multiply by y, multiply by dx. So it's pretty straightforward to get them by themselves. Then I take the antiderivative, and I get a 1/2 y squared equals x squared, and we don't want to forget our c, so we get x squared plus c on the right hand side. Okay. Now, from here, most of the time we actually wouldn't solve for y. Because in order to solve for y, I would have to take a square root. And notice I can't separate that out because of the addition. Also, in order to take the square roots, I would have to add a plus or the minus in the front. And the plus or minus would have to stay this time because I don't have a c that's like taking care of that, okay? So for your response question, you're fine to just leave it like that. Now, multiple choice question, what you're really going to see them, or like in your textbook, you would actually, more often than not, see them rewrite it like that. Any idea why? Kind of. What is that the equation of?
Circle.
It's not the equation of a circle. It would have to be addition, and my denominators would have to be the same in order for it to be a circle. For an ellipse, it would still have to be an addition sign, but the denominators are different. It's a what? It's a hyperbola. It's specifically a vertical hyperbola, so it's looking something like that. So when we have x's and y's being squared, they will tend to move the x's and the y's to one side because that is going to be your standard form of a conic section. Now, do you have to know that that's what that graph looks like? No. But just know how to get it to look like that equation so you could match it to that on a multiple choice question. But then you kind of know why. What questions do we have there? Are we ready to look at some more fun ones? Alright. What do we need to do on this one? Okay.
X and Y.
Agreed.
Could you factor out a square on the x with this board?
No, because it's addition. want to multiply by a dx and also divide by an x squared plus 4? Yes? But what do I still have that's a problem?
There's y.
There's a y, so I'm going to have to divide by a y. Okay, so what is the antiderivative of the left-hand side?
Natural log absolute value y.
You should know that one pretty well by the end of all this. Now, what am I going to have to do on the right-hand side?
U sub.
Yeah. So u is going to be,
2 for x squared to 4.
then I take my derivative, and I'm going to get,
2x dx.
and I have an x dx, I don't have a 2, but that's easy enough to move over. So again, I have a 1/2 times 1 over u du, so I end up with 1/2 times the natural log of the absolute value of u. And my u was x squared plus 4. So again, what could I do to simplify this?
Exponentiate to e.
Okay, so I'm going to have y equals, again, to simplify, I would need to bring my 1/2 up to an exponent. And we would also multiply by an e to the c, which just becomes our c in front, times the square root of x squared plus 4. Now, do you have to skip all of those steps like I did? No. But remember that it is a time test, so do you have to write out every single step? No. So, skip the steps that you feel comfortable with. But even if I left it as the second to last one, did I have to leave my absolute values there? Can x squared plus 4 be negative?
No.
No. So you could have dropped your absolute values and just put parentheses, because x squared plus 4 is always positive. But then especially once we have square root, we can really drop our absolute value. Questions on that one? Yes, no, maybe. Okay. So notice that this one's a little bit different because I have addition here. So whenever we have addition and subtraction, we do want to try and take care of that first. Because I, again, want to be able to multiply a dx over. Right now I can't do that. Or like I would get weird things if I tried to do that. So I'm going to go ahead and subtract our e term. Then I can go ahead and multiply by my dx. But what am I also going to need to do? Divide by e to the y. Okay. But how can I also rewrite 1 divided by e to the y? E to the negative y. Okay. So what is the antiderivative of e to the x? Just e to the x. So I'm just going to leave my negative there, plus c. And then on the left-hand side, what would we have to do? It's going to be a basic u sub, so I have du. It's just going to be a negative dy. So basically, we just have to have an extra negative on the front of that, because then the antiderivative of e to the u is still e to the u, and I just replace my e, or my u with negative y again. And for the most part, we would leave that one like that. We could simplify simplify it a little bit if we wanted to solve for y. Yes? So first off, notice that these are both negative. So if I multiply everything by a negative, is a negative c still a constant?
Yes.
Yep, so I can still put a plus c. And then I could take the natural log of both sides, right? Because again, those are inverses. If I already have a natural log, I raise it to the e power. But if I have an e, then I have to take the natural log. So my natural log would undo with this side. And then I would have the natural log of all of this. And then I can multiply by a negative. Again, that would only be like if it specifically asked you to have it in terms of like y equals, or if it was like a multiple choice question and you're trying to get it to match. Otherwise, you're fine to leave it here. Yes, no, maybe. What questions do we have there? You ready for the one last one? Yippee! It's a fun one. So notice that my dy and dx are kind of already separated. Yeah? So what we could do, again, if I have addition, I'm trying to get rid of my addition so that I can just multiply and divide things pretty easily. Yes? So I'm going to go ahead and subtract all of this fun stuff. So I guess I'm going to look like that. And then notice that I want to divide by a negative e to the negative x squared. And I need to divide by all y. So it's looking less yucky. But we can actually make it look even less so.
Is the dy on the left side supposed to be dx?
It is. I don't know why. I really wanted it to be a y. It's the other dy's evil twin brother. Alright, so remember that if I have a negative exponent, yeah, that like puts it in my denominator. But if it's already in my denominator, that's just going to put it in the top. So that's much nicer. Also notice that I only have one variable in the denominator, so we can go ahead and just separate that into two separate fractions. Yes, no, maybe. If we integrate the right side, it's just going to be using our basic rules. On the left-hand side, what would we have to do?
Use sub.
Use sub. But notice that we have this x on the outside and a dx. So we really just end up having an extra one. Because then I just have 1/2 e to the u plus the antiderivative of e to the u. E to the u. Now I do have to keep this negative, so it is going to be like negative 1/2 e to the u, but again our u was x squared, and then I put my plus c. And we are not solving or simplifying that, because we have a natural log of a y squared, and an x squared in our e, so there's really not much way to simplify that really at all. So that would just be our answer.